Hey guys, in this video we're going to be covering target 2C.6, and our master learning objective is being able to solve real-world problems involving quadratic equations by factoring to find the x-intercepts. Kind of a mouthful. However, the steps that we're going to be following are going to be right up here at the top. So if you ever get stuck, please refer back to that. So our first example, the length of a rectangle is 5 centimeters more than the width, and the area is 36 centimeters squared. Find the width, find the length. Well, if it tells us we're dealing with a rectangle, the first thing that would be good to write down is that the area of a rectangle is equal to the length times the width. And you could abbreviate, that's fine as well. Alright, now we have our rectangle. Draw myself a rectangle here. And it tells me that the length of the rectangle is 5 centimeters more than the width, right? More than means addition. We don't know what the width is, so I'm going to let the width be some variable. And I'm going to say the length is 5 more than that. 5 more than x would be x plus 5, right? 5 more than. So now all I have to do is I'm going to go ahead and substitute on what everything is in my equation. So my length and my width, I have x times that x plus 5 equals the area, right, which was 36 centimeters squared. Anytime you see, if they don't clearly tell you that the area is something, look for the units squared. Anything that has units, like, for example, centimeters squared, that gives away the area. All right, go ahead, and now we're going to multiply the binomial, which is my step 2. So I'm going to multiply x times x. That's x squared. Multiply x times a positive 5. That's a positive 5x. Still all equal to 36. Alright, next step says set equation equal to 0. So that 36 needs to move over to the other side. So I need to subtract 36 over. And that's going to give me an x squared plus 5x minus 36 equals 0. Alright, that brings me to step 4 that says factor and find the zeros. So I'm going to use my Punnett square box here. Substitute an x squared, my negative 36. And I'm thinking of numbers that multiply to a negative 36 but add to a positive 5. So they are going to have alternate signs. And that's going to be 9 times a negative 4, right? That equals a negative 36. And then if I were to add or subtract these together, I do get a positive 5x. So in one box, I'm going to have a 9x. In the other box, I'm going to have a negative 4x, which brings my binomials to be an x plus 9 and an x minus 4. All right, but I'm not done because I still got to find the x-intercepts. So therefore, x plus 9 times x minus 4 set equal to 0. That would give me an x equals a negative 9 and an x equals a positive 4. Now, when we are dealing with real-world problems, there is something you have to remember. We cannot have negative answers, right? It doesn't make sense to say that our width was negative 9 centimeters. So you cannot use negative answers. If you want to write that for yourself, you can. I'm going to go ahead and box it that my answer is only x equals 4, because we cannot have negative answers. So only take that positive, and then we're going to take that positive and we are going to substitute it in to figure out what my length and my width is. So if I'm saying x is 4, I'm going to plug it in over here where I see x and where I see x. So what that's going to be then is that my width is just 4, right? And my length, well, that's going to be 4 plus 5, which is equal to 9. Right? So my width is 4, my length is 9. All right, let's try another example. Example number 2 says the length of a rectangle is 2 centimeters less than the width, and the area is 99 centimeters cubed. That is a typo there. That should say squared. Find the width and the length. So in this case, still having a rectangle, so I still know I'm going to be using area equals my length times my width. Have my rectangle If it says that the length is 2 centimeters less than the width, less than means subtract. My width is some variable. My length is 2 less than that. So I'm going to have x minus 2. But the setup is all the same, right? I'm going to have my width times my length. Again, doesn't really matter the order you have those as long as you're still multiplying. Equal to that area there, which is a 99 centimeters. That should say centimeters squared. So it's going to be equal to 99. And then we're going to distribute, right? X times x is x squared. X times a negative 2 is a negative 2x. And that's still all equal to a negative, or to a positive 99. It does need to equal a 0, so I'm going to go ahead and subtract 99 over to the other side. Alright, this is my dotted line. So that's going to give me an x squared minus 2x minus 99 is equal to 0. Alright, I'm going to use my Punnett square box then to help me factor this. So I'm looking at my x squared. I have a negative 99, so a number that multiplies to a negative 99 but adds to a negative 2. And that's going to be a negative 11 and a positive 9, right? That multiplies to a negative 99. And when I were to add these together, I do get a negative 2x. So a negative 11x and a positive 9x. So that's going to give my binomial, it's going to become x minus 11. And x is a positive 9. Writing these out, x minus 11 times x plus 9, all equal to 0. That becomes x is a positive 11, x is equal to a negative 11 or negative 9. But remember what I said before, we cannot take negative answers. So x cannot equal negative 9. X can only equal positive answers, and that would be x equals a positive 11. So I'm going to go ahead and substitute that back in, which is going to give me my width of 11. And then 11 minus 2, and that would give me 9. Right? Don't forget to go back and substitute it into our example here. All right. Next example, example number 3, says that Kelly had a garden that measured 3 meters by 6 meters. She's now growing to plant more tomato plants and needs a total area of 70 meters squared. If she increases both the length and the width by the same amount, find the distance that each dimension was increased. What is the new length and the new width of the garden? Alright, so looking at that next example, start off drawing yourself a picture, right? What do we know already? Well, we see that rectangle there. It's a 3 by 6. So this is a 3 and this is a 6. We want to increase it though to be uniform length all around, right? So we want to add some length. We don't know what that is, so I'm going to say that's an x. And that's going to be all of this, but then I want to add a little bit more on this side. But again, it's the same thing, so I'm also going to add x, right? It's like a uniform pathway all the way around. So now with the size of my rectangle is a little bit different, right? I have an x plus 6 plus x and a 3 plus x. Not going to change the way I set this up, right? I still am going to use those two binomials, 6 plus x times 3 plus x, right? Equal to my area, which was 70 meters squared, so equals 70. And I'm going to go ahead and multiply this. A little bit more distribution, so I'm actually going to use a Punnett square box just so we don't lose any terms and we can, keep everything nice and organized. So 6 plus x and 3 plus x. If I multiply these out, I get 3 times 6, which is 18. 3 times x is a 3x. 6 times x is a 6x. And x times x is x squared. I'm going to go ahead and put this in order for myself. So I know that the x squared is the biggest exponent. So I'm going to write x squared. I see my diagonals are like terms. So 6x plus 3x is a positive 9x. And my last term, which is a plus 18, still all equal to 70, which I have to change, right? Because I do want it equal to 0. So what I have to do then is I have to subtract 70 on both sides. So now I have an equal there. I have an x squared plus 9x. But now 18 minus 70 is going to be a negative 52. Alright, that now is what I'm going to be factoring. So I'm going to use my Punnett square again, but a little bit differently, right? Because I have to find the outsides of the Punnett square box. Because now I have an x squared here, but I have a negative 52, and I have to add to that middle term, which is a positive 9x. So numbers that multiply to a negative 52, add to a 9, messing around with your multiplication chart or just kind of dividing 52 by numbers, you will see that it is a positive 4 and a negative 4 and a positive 13, because if I were to add these together, I do get that positive 9x. So therefore, I have a negative 4x and a positive 13, which makes my outsides x minus 4 and x plus 13. And then my binomials become x minus 4 times x plus 13, but that did not ask me for the binomials. I need to find the x-intercepts. So that's going to be x is a positive 4 and x is a negative 13. But again, no negatives, right? No negatives, which makes my only answer then a positive 4. Now, if it's asking for that new length, I know that that x is 4, so I do have to plug in that x on both sides, right? So then that 6 plus x, which was 4, right? So that total width then is going to be 10. And then 3 plus 4 is going to give me that total other side to be 7. All right, so in case my width and my length now should be 7 and 10. All right, next example. Example number 4. You are constructing a frame of a photo that measures 8 inches by 12 inches. So I'm going to kind of draw my picture as I'm reading along here. So an 8 by 12. You want the frame to be the same width all the way around, and the total area of the frame and photo to be 140 inches squared. So that's eventually going to be my area. What is the width of the frame? What are the outer dimensions of the frame? So what I want to do, though, is I want to make sure that I'm adding a frame around my picture. So, and the width all the way around my frame is going to be the same distance. So what that means then is that this length right here from the picture to the frame is an x, and this length from the corner of the picture to the frame in this direction is also an x. So what that ends up kind of being for myself is that if I see on each side of my picture frame, the total length then from this distance, including my picture, and this distance, would be, well, how many x's do I have? I have an x here, and I have an x here, and this was 12. So therefore, this whole side is going to be 2x plus 12. All right, let's look at the other side. I see that this is an distance from here to here is an x. Distance from here to here is an x, because that's the frame. And then the actual picture, though, was an 8. So if I have an x, an 8, and an x, this total distance on this side is going to be 2x plus 8. All right, so that's my length and my width. So I'm going to have 2x plus 8, 2x plus 12, all equal to the area, which is 140 inches squared. I'm going to go ahead and use my Punnett square box to help me multiply these out. 2x plus 8, 2x plus 12, multiply. 2x times 2x is a 4x squared. 2x times 8 is a 16x. 2x times 12 is a 24x. And 12 times 8 is 96. Writing all these terms out, I have 4x squared. I'm going to combine my diagonal here, so 24x plus 16x. So combining those two diagonals, 24x plus 16x is going to give me a plus 40x. My last term plus 96 is still all equal to 140. All right, we want to make sure that our equation is equal to 0, though. So that 140 has to move over to the other side. So I do the inverse, right? It's a positive 140, so I'm going to subtract 140 over to each side. My equation is now equal to 0. And what I'm going to try to factor now is 4x squared plus 40x. And 96 minus a 140 is going to be a negative 44. All right, I want to make sure I factor that now using my fun and square box. So this is going to be a 4x squared. But actually, before I even write this, I noticed that I can probably simplify each of these terms by a number, right? And I'm going to try to remove actually a GCF before I even try to factor, making it a little bit easier for myself. So if I look at all those coefficients, they can all be divided by 4. So my GCF here is going to be a 4. So I'm actually going to remove that over here, and I'm going to say 4 times, if I divide this, it's going to give me x squared plus 10x minus 11. That makes it way easier to try to factor than trying to deal with those big numbers. All right, so let's try this again. So I have an x squared here. I have a negative 11. Now I'm thinking of numbers that multiply to a negative 11 but add to a positive 10. And that would be 11 times a negative 1, right? That's a negative 11. And 11x plus an x, or minus an x, my fault, minus an x, is going to be 11 minus x is going to give us our 10x that we need. So I'm going to go ahead and put those terms in, 11x, or minus x, and that's going to give me an x plus 11, and an x minus 1, and write those terms out. So x plus 11 times x minus 1 equals 0, but I can't forget that 4, right? My GCF in front. So each of these equal to 0, so x is going to equal a negative 11, x is going to equal a positive 1, but don't forget we cannot include negative numbers, right? We can only take our positive answer there, which would be an x plus 1. All right, so all that's telling me is that my frame, though, is a 1. That does not tell me what the length and the width is, so I do have to go back and plug in that total length and width, including the frame and the picture. So what that's going to be then is I'm going to substitute, right, 2 times my x, which is a 1, plus 12. That's going to give me 2 plus 12. So that one side is going to be 14. And my other side here would be a 2 times 1 plus 8 is going to give me 2 plus 8, and that's going to equal 10. So those are my two sides, 14 and 10. All right, last example for this note packet is going to be example number 5. It says a square is altered so that the dimension is increased by 4, while the other dimension is decreased by 2. The area of the resulting rectangle is 55. Find the original length and other lengths of the original lengths of the sides. Then find the area of the original square. So if I had a square, square means that each side is the same, right? But then, on the other side then would be subtracted by 2. And this would be a minus 2 here. So my binomials then would be an x plus 4 and an x minus 2. All equal to our original area, which was a 55. Alright, so using my binomial here, I'm going to use my Punnett square, x plus a 4, x minus 2. That's going to give me x squared plus 4x minus 2x minus 8, x squared. Combine my diagonals there. It's going to be a positive 2x minus 8 equals 55. I still want my equation equal to 0, so I have to subtract 55 over to the other side. And that's going to give me x squared plus 2x. And then I have that minus 8 and a negative 55. That's going to give me a negative 63 because they're both negatives. Equal to 0. I'm going to go ahead and factor that now using my Punnett square box. Top left is going to be x squared. Bottom right is a negative 63. So a number that multiply to 63 but add to a positive 2 is going to be 9 and 7. Right? 9 times a negative 7 is a negative 63. And if I were to add these two together, I would get a positive 2x. So 9x minus 7x makes the outsides of my binomial x plus 9 and x minus 7. X plus 9, x minus 7, all equal to 0. So my x-intercepts would be a negative 9, and x equals a positive 7. But remember, I cannot take negative answers, so my x is just a positive 7. Figuring out the original area of my picture here then, as well as x and x is on each side, all I have to know then is that it is a square, so therefore each side equals 7. Alright, if it asked me what the new side was, you could just add those 4 or subtract that 2, and then again it would be 7 plus 2, which is 10, and 7 minus 2, which would be 5. Right? You can go ahead and work on the next video or on the next activity, which is target 2C.6.